So in this unit, we are going to look at chemical reactions. So before we start with chemical reactions, let's do a review of our Unit 2 material. All right, we talked about physical and chemical properties and physical and chemical changes. Remember, a physical property is one in which a characteristic of a substance that can change without changing the identity of that substance. A chemical property is the ability to cause a change in the composition of matter. It completely changes from one form to a different form, and it can only be observed when that substance changes from one form to another. So what I'd like for you to do is pause this video, and I'd like for you to go through and determine these examples. Are they physical or chemical properties? Okay, so tearing paper. If I tear paper, it's still paper, so that is a physical property, and I'm just going to write P for physical. Burning paper. If I burn paper, it becomes ash. I cannot get the ash back into the form of paper, so it is chemical. I'm going to write a C for chemical. If I melt ice, it has gone from solid water to liquid water. Water is still water, so that is physical. Rusting metal. Once metal rusts, we can't get the rust away, so that is a chemical reaction. It becomes something new. Dissolving. Any type of dissolving is physical. And think back to the demonstration we did where I put salt in water and then we let the water boil out and the salt was left over. All right, so the water still has this sugar in this example, and in our demo it was salt. All right, but it's the same concept. Both is still there, the sugar and the water. All right, it has just dissolved. It has broken apart. Zinc and hydrochloric acid becomes zinc chloride and hydrogen gas. So I'm taking two things and making two new things. When I make something new, that is a chemical property and change. So a chemical reaction is going to be a change in which one or more substances are converted into different substances. So a chemical reaction is like a chemical change. We're taking one thing and making something new. So if I have substance A and B, they become substances C and D. For example, in our last example, what kind of property? Maybe A is zinc, and B is hydrochloric acid, and maybe C is zinc chloride, and D is hydrogen gas. So I'm taking something which we call the reactants. So the reactants are on the left side. That's what I start with. And I am making something new. We call those the products. The products are on the right side, right? If you have a final product that you turn in as what you're going to turn in for a grade, that's what you created, all right? So products are created. Now, chemical reactions are going to follow our law of conservation of mass. And the law of conservation of mass states that matter is not created or destroyed, it simply rearranges. All right, and what that means, if we look back at our example, zinc, hydrogen, and chlorine are on the reactant side. Zinc, hydrogen, and chlorine are on the product side. They're just in a different order, a different form. So we have not lost any matter in this equation. We've just made it look different. All right. So our law of conservation of mass states that chemical reactions must obey this law. So chemical reactions have to obey the law where the number and type of atoms must equal on both sides. So the number and type of atoms as the reactants must equal the number and type of atoms as products. So basically mass in equals mass out. So for example, a reaction has 5 grams of reactants. How many grams of products are produced? So if mass in, 5 grams, equals mass out, how much mass do I have come out? If I start with 5 grams, I have to have 5 grams coming